This is Unit 7, Section 5, Notes, Graphing Log Functions. Alright, so letter A is just graphing basic log functions, so we want to graph each function. Alright, so again, we need some notes, of course. So we all know that we have y equals log base b of x, okay? Now, we have growth and decay, just like with exponential. Okay, so with growth, the way I find out if it's growth or decay is the same as exponential. I look at my b. If my b is greater than 1, it's growth. If my b is less than 1, it's decay. So that doesn't change, it just is in a different spot. So the graphs for these, a growth graph will start to the right of the y-axis at the bottom and go up, and then curve out. And then decay starts at the top of the y-axis and goes down and then curves out. So notice it's just like the exponential functions, but now it's turned sideways. So instead of going away from the x-axis, it goes away from the y-axis. Now the nice thing about logs is you can't have a positive and negative growth and decay. There's no such thing as negative because it cannot go to the left. Okay, so that's the basic graph, but on logs, again, it can only go right, it can never go left. So that kind of makes it a little easier. Then we have domain and range. Okay, maybe I should have spaced this out a little bit, that's okay. So, I have domain for a growth function is x is greater than h, and domain for a decay function is, ironically, also x is greater than h. Now again, because I don't have negative growth decay, I can never flip that, so that is always going to be true. My range. The range for both of these is now all real numbers. So again, if you go back and look at the exponential graphs we did, it's just flipped. So remember on the exponential, domain is all real numbers, now it's range. So they're inverse, that's why they flipped. Alright, then the last thing we're doing right here is end behavior. So I have x approaches positive infinity, f of x approaches. So again, if I'm growing, as I'm going to positive infinity, I should be going to positive infinity. That makes sense. And then as x goes to negative infinity, instead of k, remember last time it was k, well now it's inverse. So we've been using h. Whoa, I need an arrow. We're going to be going to h. Okay? So again, it's just the exact opposite of what we did before. So decay, as x goes to positive infinity, f of x goes to h. So again, it's just a reverse of growth. As x goes to negative infinity, f of x goes to positive infinity. So I take my answers and I change them. So that's all we got to do right here. Okay, that's a basic log. So let's look at these. My base tells me growth or decay. Well, my base is 4, which is greater than 1. So this is a growth. Okay, so it's growth. And then, so I know range, all real numbers. Okay, that's always going to be true. Domain, x is greater than k. Well, I don't have a k, so it's just 0. And we'll go over k in a minute. I didn't do k right now, I just wanted the basic. So domain, x is greater than 0. In behavior, so we have growth. Oh, I did flip those. I apologize. That's my fault. My fault. Because yeah, we're flipping. I should have known that. All right. So flip these. My mistake. But at least I caught my mistake early on. So I mean, they're still in the same order as far as what goes first, what goes second. So this one is positive, and this one's h. And then decay, you flip them, I would have h and then positive infinity. Okay, totally my fault. I take blame for that. But we fixed it now, so we can move on and get the right answer. Because yeah, notice everything's flipped, so now our blanks are first, and the f of x is always the same. So growth, with the positive infinity, I would have positive infinity. Then with negative, I have h, which again, I don't have an h, so it's just 0 for now. And I'll go over the h and k in a minute. So for my graph, I'm just going to draw this one right here, just a basic growth. I start to the right of the y-axis and go up, and then just go away. And that's it. Okay, now let's do this one. If you guessed that one's growth, this one's going to be decay, because it is. So there's my b. So that one's less than 1, so it is decay. So my domain, well, my range, first off, all real numbers. Domain, x is greater than, no h, so it's 0. Or did I say k earlier? My bad. Okay, here I flip them. So I have 0 and infinity. And then if this works, right? So decay on a log, I start at the top and go down to the right. And that's it for that part. Moving on, instead of y-intercept, now we have x-intercept. This one's a little different. So instead of changing x to 0, I now change the f of x to 0, and then I can solve from there. So I change f of x to 0. I have the log by itself, so I can convert. By that, you have b, a, x. So I convert it to 4 to the 0 equals x. Anything with a 0 exponent, of course, is just a 1. I have nothing else to do, so that's my answer. 1, 0. Easy. Of course, that one was the basic one. Let's do one with a little bit extra work. Only one extra step. Alright, so I replace f of x with 0. And my pen just changes colors. Nice. Alright, again, the log is by itself, so I just convert. I'd have 3 to the 0 equals x minus 3. Because we have b, this is our a, and that's our x. So I want b to the x equals a. Alright, now 3 to the 0 is 1. And then I need to solve for x, so this is my one extra step I told you about, plus 3. So my answer, or not my answer, but my x value is 4. So my answer is 4, 0. Okay, this one, it's a different step, same thing. So replace f of x with 0, write my log, whoops, forgot the x. Now notice my plus 2 is not in parentheses, that means it is not with the log. So if you need to, put parentheses right here. Now I have to move that 2 because I cannot have anything with the log before I convert. So I switch that over there. Now I can convert my log to exponential and solve. So I would have 1/5 to the negative 2 equals x. Remember, negative exponents flip the number, so I'd actually have 5 squared equals x, which is 25. So my answer, 25, 0. So don't just put 25, that's nothing. You gotta have a point, because it's asking for x-intercept, not a number. Alright, next, asymptotes. You are gonna like this. The asymptote for a log is simply h. So asymptote for logs, the way you would write that is just x equals h. And remember, h flips or changes signs. That still applies. So let's look at number 6. If I wrote parentheses right here, notice there's no number. So if I don't have a number, it's the same thing as 0. So x equals 0. Can't put negative 0, that doesn't exist. 7. I only want this one, I don't want k. So if it's x plus 5, h is actually negative 5. So my answer, x is negative 5. Same thing here. I want parentheses, not that. So h is 7. So x equals 7. And that's all asymptote is h. Last thing is graphing log functions. Okay, I've already gone over, well, pretty much all of these you have written down somewhere in the notes above, so I'm not going to write anything else again. We're just going to go through these real quick. Of course, first thing you want to look at is your b, your base. 1/4 tells me this is decay. If it was greater than 1, it'd be growth. Okay. And then if you want to label, you can. I want h. I don't really need k. That doesn't help me for this. Okay. So h, actually we'll write h is negative 3. You don't want to accidentally write the wrong one. So domain is x is greater than h, which is negative 3. Range, always all real numbers. In behavior, because this is decay, my negative infinity goes to positive, and my positive goes to h. So that's nice. Oh wait, no, I actually have that backwards. Oh, no, that was right. Okay. So yeah, that's right. H and, okay. I'm tired. That's all it is. I need coffee. Alright, so it's h in positive infinity. X-intercept, we got to solve for that. I do know it's going to be something, comma, 0. I got to solve for the x. And the asymptote is x equals h, negative 3. Okay, so let's go find the x-intercept. Same thing we just did, replace f of x with 0, and then we can solve for x. So we got to get log by itself, subtract 1, okay, log is by itself. Now we can convert. So we have b, a, and x. We switch it. So we'd have 1/4 to the negative 1 equals x plus 3. A negative exponent flips. So 4 to the 1, which is just 4. And then I solve for x. So this one would be 1 is my x value. So I go over here and put a 1. So just like with exponential, this is the order I can graph in. I do x-intercept, then asymptote, and then the growth or decay. So x-intercept is 1, 0 right here. Asymptote, which I guess I didn't write anywhere, but if you want to write it here, you can. So for exponential, it's horizontal. For log, it's a vertical. It's still dotted. I always tell people, you dot the line because you never want to touch anyone's asymptote. At least the function doesn't need to. So, x is negative 3, and I do a vertical line all the way up. And because I'm decay, I would start at the top, right by the asymptote to the right. I go down through the point and go away from the y-axis. And that is it for this section.